Electrical design consideration for tall buildings. There has been a sharp increase in the development of extra-tall buildings, usually multi-purpose and often consisting of a retail and/or entertainment podium and towers of commercial offices, hotels and residential facilities. First of all, every tall building is supplied with multiple sources of electricity, including feeds for normal power, usually supplied by the local electrical utility company, LUC, and an emergency or standby source of power, usually supplied from on-site engine generator sets. The LUC supplies the building with medium voltage power from one or more utility substations. Ideally, the supplies are fed from multiple substations to increase the reliability of the main electrical system. The utility supply will enter the building from below grade and usually terminates in a main switch room. Often, the location of this electrical room depends on the demands of the LUC. A significant concern is that each LUC has its own idiosyncrasies. In some jurisdictions, the LUC has no requirements for the main switch room at all, and it can be located anywhere within a basement area. In other jurisdictions, the LUC may require that the main isolation equipment, switchgear or ring main units, be located as close as possible to the outside wall where the service enters the building. Other LUCs, such as the Dubai Electricity and Water Authority, DUA, in the case of Dubai, may demand that this isolation equipment be located in a room at street level, directly accessible from the outside or in a completely separate building at the site property line. Therefore, it is essential that the electrical engineer contacts the LUC as early as possible to determine if there are specific requirements for the service entrance equipment and its location. At this early stage, the engineer also should determine the codes and standards that the LUC requires for electrical system design. The engineer will likely find that the LUC has a set of additional design requirements specific to local conditions and local practices. Often these are not obvious, and if the engineer does not uncover these early, it can be costly to the engineer and to the owner. The medium voltage supply must be transformed down to the utilization voltage, 480 volts in the United States, 600 volts in Canada, and 400 volts or 380 volts in much of Europe and Asia. In standard buildings, the transformers are located at or below ground level. In extra-tall buildings, transformers at low levels are insufficient. At some height, the voltage drop caused by the impedance of the supply conductors will become significant and the supply voltage will fall below acceptable values. The architect's design must therefore accommodate service levels in the upper parts of the building, in which additional transformers are located. Selecting the location of the service level requires cooperation between the engineer and the architect. The engineer will require the service levels to be located where they can adequately service selected floors. The architect will consider issues such as the impact on the aesthetics, the space requirements and space constraints, the impact of the service space on adjacent spaces and the transportation of equipment to and from the service room. In the Emirates Towers, the transformer rooms at the upper level are located close to the elevator shafts, so that transformers can be transported through the elevator shaft in the event that one must be replaced. Medium voltage cables must be fed to the transformers on the upper levels. Frequently, the owner or LUC will demand that the medium voltage cables be kept completely separate from any low voltage equipment and routed up the building in separate accessible spaces. The access is necessary so that the cables can be secured and supported at regular intervals so as to relieve stress on the cables, and to limit their movement under short-circuit conditions. But what about emergency power? To ensure safety in the event of a normal power outage, emergency power generation is required. The emergency generators also may be used to provide a reduced level of service to non-critical items. When selecting the generation system, the electrical engineer must decide between low voltage or medium voltage generators. Selecting medium voltage generators allows for the use of fewer, larger generating units, all of which can be located at a low level. However, a medium voltage emergency system will require a sophisticated transfer scheme, more costly than low voltage equipment. In addition, some looks will not permit the use of such an arrangement. Conversely, selecting low-voltage generators will require more generator units. And due to voltage drop, they will have to be distributed throughout the building on service floors. Moreover, electrical and mechanical engineers must coordinate their work to ensure that sufficient combustion air and ventilation is provided to the generator rooms, and to ensure that the exhaust, fuel and cooling systems are correctly designed.